Hello and welcome everyone. Thank you so much for joining us today for this live webinar. We are delighted to host you. My name is Ben Lawrence. I am part of the sales team here at Gecko, and I'll be your host as we walk through the webinar that we've created for you today. Now, a little later on, joining us is going to be one of our Gecko colleagues, Chase David. Chase is a true subject matter expert on all things non-destructive testing, robotics related, and he's going to be giving us a deeper dive on some of the more technical aspects. The purpose of today's webinar is to familiarize you with a new technology-enabled approach to optimizing tank farms in the industrial world. The format that we're going to be following is a presentation that lasts roughly 30 minutes. So this is a 30-minute presentation followed by 15 minutes that we'll set aside at the end to answer any questions that you submit during today's webinar. So it's 45 minutes in total. Now, if you have any questions or comments, please submit them via the chat function in the webinar interface. And that chat function is labeled as a Q&A button. So at the bottom of your screen, you're going to see a Q&A button, and that's what you can press in order to submit your question. All right, so with that, let's jump right into today's webinar. Now, if you're not familiar with Gecko or you haven't heard much about us yet, for the last decade, our company has been traveling the world doing all kinds of work at industrial sites. But over that 10-year period, we have conducted roughly 2,000 tank optimization projects. And of those projects, we've been able to collect over 1 trillion data points. Now, in that period, this is why it's important to you. Working with our customers, we found that there are 3, I would call them conclusions or frustrations that our customers report as it relates to the traditional approach to inspecting and maintaining tanks. The first conclusion is that traditional inspection methods are complicated. Now, we know those traditional methods often require us to empty, degas, and clean the tank, which is not only expensive, but it leaves us prone to EPA fines and safety threats, and sometimes valuable time offline. Now, the second area of frustration that nearly every industrial site seems to have is maintenance surprises. And I don't mean the good kind. Now, since these traditional inspections cannot cover every square inch of the tank, when your maintenance team goes out to perform those repairs, they find surprises in the form of additional repairs that they have to do. And sometimes those additional repairs also require additional parts that in this post-COVID world are nearly impossible to source. In fact, we had one customer recently that put together a $1 million maintenance plan for their tank farms, and that $1 million quickly grew to over $5 million because of the additional maintenance surprises and supplies that they had to buy on an emergency basis. Now, the third frustration, and this may be the biggest conclusion of all, is that our customers at the end of a traditional inspection, you're left with a very weak data set. Now, traditional inspections give you data on only 1% of the surface area, meaning you're 99% blind to where those problems are in the first place. Boil it all down, and we've learned that tank inspection in today's world is still a manual process that looks a lot today like it did 30, even 50 years ago. But it doesn't have to. In fact, your best-in-class industry peers have found that there's a new way to solve problems. And this new way brings 3 fresh ingredients to your table. So let's talk about those. Now, the 3 technologies that your industry peers are finding are very helpful are, number 1, robots. robots like the one in this picture that are covered in ultrasonic, phased array, and other types of sensors that conduct a complete health scan over every square inch of your tank. In fact, in some cases, they conduct that health scan over every square millimeter. And we now even have a tank that's submersible. We call it our swimmer, that can inspect many tank floors even while the tank is on stream. The second ingredient are sensors. Now, once the robot has detected the hotspots or the problem areas on your tank, we can stick some continuous corrosion monitoring sensors directly on those hotspots to keep an eye on things, and those sensors will trigger maintenance at exactly the right time. And in just a moment, Chase is going to walk us through some specifics related to those robots, and then I'll show you what the sensors look like. Now, the third ingredient is software. Now, once the robots and the sensors have done their job, we then have a software system that goes to work and really starts to drive value. And again, you're going to see that in action just a little later on in this presentation. So with that, I'm going to turn it over to Chase. And Chase, if you can just introduce us and give us an overview on these robots and what they're all about. And by the way, while Chase is doing this, you're going to see some live action here at our lab of what these robots look like while they're doing their job. So Chase, over to you.
All right, thanks, Ben. Shown behind Ben is a couple robots that we have that have a payload called RUG, or Rapid Ultrasonic Gridding. These are corrosion screening robots that have 1 inch by 1 inch transducers. They have 1 inch by 1 inch space transducers. The transducers are about a 1/4 inch to 3/8 in diameter, depending on the work that we will be doing with them. These robots can cover up to 5,000 square feet or more in a 12-hour work shift. That gives us the ability to do about a 100-foot diameter tank in 1.5 to 2 shifts, bringing that typical 30 to 45 day complete screen with the older type of technologies down to just a few days. The data or reports delivered can be done in a 3 inch by 3 inch bin or a 1 foot by 1 foot bin, showing the hot spots of the corrosions at the time of the inspection. Afterwards, if there's some areas of interest that have some pretty severe corrosion or something you'd like to really dive in deep on and get better fidelity on, we have a phased array robot similar to the one shown here that has a 1 millimeter by 1 millimeter resolution for follow-ups in those hotspots that are seen in that RUG data. So not nearly as quick. It can do about 500 to 1,000 square feet a day. So roughly 1/4 or 1/5 of the typical what RUG could do. So it takes much longer to do a whole tank with it, which is why you want to go and use RUG on the whole tank and just 1 or 2 days cover 100% of it, and then come in and maybe do a 2 foot by 2 foot, a 4 foot by 4 foot, and 5 to 10 areas of interest, maybe near a fill line or some corrosion area with this phased array robot, and you'll get about a 1 millimeter by 1 millimeter resolution. Also, not shown here, a very similar robot to this has a weld inspection apparatus on the front of it using phased array for nominal thicknesses of a 1/4 inch through 8 inches thick. So it covers a wide range of all types of carbon steel material. It'll work on just about any tank design that's out there. This design can also do 1 millimeter indexed resolution, so very, very high resolution. And it covers roughly 500 linear feet up to about 1,000 linear feet per shift. So on a 100-foot tank, that could be done in roughly 3 shifts. So just maybe 4 to 7 shifts, you can get a complete comprehensive scan of your complete storage tank on a 100-foot diameter tank, where that normally would take upwards of 45, 60, or even 90 days, depending on how many tools you're going to throw at it. You can do that in just a week's time frame, that or less. Back to you, Ben.
Thank you for that overview. And by the way, I don't know if you could see that while Chase was going through his demo, but we also have a robot pilot who's been driving this the whole time. So if you say hello to Alexei over to my right, Alexei is one of our certified robot operators. And when these devices come out to your site to complete these inspections, guys like Alexei are there to guide you through it and make sure that it's done properly. Now, in addition to the robots, you may recall the second of these ingredients is a continuous monitoring sensor. So to give you an idea of what that's all about, we actually have right here, this is one of the sensors that we will use. So once the robot has identified the problem areas on your tank, this is the continuous corrosion monitoring sensor that we go over to the tank, and wherever the problem area might be, there's a very strong magnet, so we just stick that corrosion monitor right on the tank, and moving forward, that is what's going to tell us every day what the corrosion level is in that area and is going to trigger maintenance at exactly the right time. Okay, so boil it all down. We have robots, we have sensors, we have a software program, and what your best-in-class industry partners are discovering is that when they bring these ingredients to the table, it transforms their day-to-day world from one that looks a lot like this, what you see on the screen now, to a world that looks like this. And to summarize that, what are the benefits? Okay, well, this next chart is going to show you what the benefits are, but walking through this list, number one, it's asset availability that moves from being at risk to secure. The second is the duration of the inspection itself that goes from many, many days to just a few shifts, as Chase described. Third is that in many cases, we no longer have to de-inventory and de-gas that tank. The coverage area goes from 1% to very close to 100%. And then finally, we don't have to mess with the ropes and the scaffolds and all of the complications and challenges that come along with those. Now, if you're at the department level, that may be reason enough, right? Just to make this transition and have a simpler inspection or scanning process could be enough to justify this change. But if you're in maintenance or reliability or any sort of leadership role, you may be more concerned about the business outcome of this transformation, and that's where most of the value lies. So let's explore why this is such an important transformation for your business as a whole. Now, when we talk about value to your business as a whole, your industry peers are reporting that there are really three new value categories that this approach opens up. The first is compliance, the second is maintenance, and the third is CapEx. So we're going to walk through each of these so that you can understand how these value opportunities come alive within your plant. And let's talk first about compliance. Now, on the compliance side, we hear from our customers that they usually think about compliance as a cost center, right? Like a necessary evil. It checks a box for compliance purposes, but it does not help them drive profit. So the first thing that we want to do is transform compliance from a cost center to a value driver. And here's the way that we go about doing that. Number one is we shift compliance from an exercise of a cursory health check to a comprehensive health scan. Now, I like to think of the difference between these of the difference between you and I as normal humans going to our local doctor and getting a health check that's really just our doctor putting a stethoscope to our heart, versus imagine the type of health scan that a top athlete is going to receive at the NFL Combine. So major difference in how we go about doing these health scans. But that comprehensive health scan then enables us to move from maintenance that's usually time-based or reactive to a condition-based maintenance model. And that condition-based maintenance model becomes the engine that drives huge impacts in reduced unplanned downtime. So this is the cycle related to compliance that opens the door to driving a lot of value in the two other areas that we talked about previously. So number one, maintenance. Remember, that was category number two. Now, in the maintenance arena, The first opportunity is for you to do better precision maintenance today. And this is what it looks like. What we're looking at here is a true three-dimensional digital twin of your tank. Now, this digital twin is built 100% on the actual health data that the robots gave us. There are no assumptions or leaps of faith. We're not trying to fill in blanks like you might find in other systems. This is a 100% accurate and data-backed model of your tank that shows you exactly where your maintenance team needs to direct its efforts today. Now, the second area within the maintenance category that you can see a lot of value is using predictive analytics for future maintenance planning. Of all the features that we're going to talk about today, this may be the hardest to replicate or build internally because it's built on thousands of jobs and trillions of data sets that took over a decade of global work to build. But at the end of the day, the value to you is that you have a model that's going to show you not only where maintenance is today, but where corrosion is most likely to occur 1 year, 3 years, 5 years, even 20 years out. So think about the next time you're going into a turnaround, and if it's 2 or 3 years to that turnaround, you can start planning today with precision what kind of maintenance you should expect at the time of that turnaround. Now, the third area within the maintenance value category where our customers are reporting a lot of value is for the first time ever building a stack rank prioritization of exactly what maintenance your team should do and the order in which they do it. Now, this stack rank prioritization is built on 2 different inputs. Input number 1 is the health data that our system was able to derive for you. The second is your criticality list. So based on asset criticality across the entire tank farm, which tanks are really most important to your process? When we blend health data and asset criticality into one chart, it allows your maintenance team to do maintenance in a much more precise and formative way than they have in the past. All right, so we've talked about compliance as a value category. We've talked about maintenance. Now let's talk about CapEx. In many cases, this is the most immediate opportunity for you to save millions of dollars. Now, this might sound a little disturbing, but what we have found across pretty much every industrial site in every organization is that somewhere between 10 and 20% of the time, companies make a bad decision. They decide to replace tanks that they could have repaired for pennies on the dollar and gotten just as much life from them. Now, in this case, we're looking at a tank where our customers, based on cursory health data, thought that they had to replace it at a cost of over $3 million, when in reality, they were able to do long-term maintenance for about $200,000 and get just as much life. The takeaway for you is if you have any tanks on your farm that you're considering replacing, please hold off on doing that. Let us help you with a cursory and comprehensive health scan so that you can make an intelligent decision and avoid wasting millions of dollars. Okay, so again, back to this final chart. What are the value categories? 3 steps. Number 1, it's shifting compliance from a cost center to a value driver. Second is shifting your maintenance on these tanks from something that's reactive or time-based to something that's condition-based and forward or future thinking. And then finally, when it comes to CapEx, eliminating needless replacement and instead doing intelligent and data-backed repairs. So what does that look like from a real-world perspective? As we wrap things up here, let's take a look at a real-world case study. Now, in this case, we're looking at some information from a very large paper mill here in the United States that has over 60 tanks on location. And when we went out and did our tank optimization across that farm, what we found is that for whatever reason, 5 of those tanks were in awful shape. Now, all the tanks were of similar vintage and performing a similar task, but 5 of them were way worse than the others. Now, the customer's first reaction was to replace all 5 of those tanks at an enormous cost. But we calculated a new load balance. Now, that may be a new term, but it's an important one. A load balance strategy that allowed them to simply reduce the volume in those least healthy tanks and reallocate that volume over to the tanks that were healthiest. Now, it seems simple when we think about it on paper, but the analytics and the comprehensive health data that goes into shifting that load intelligently across the farm is really quite extraordinary. Now, in addition to helping them with load balance, we're now going to the next level of value. We're pulling in process data, things like mixture ratios and flow rates and temperatures, to determine what caused so much damage on those 5 tanks in the first place. The whole strategy here, folks, is to build out new operational SOPs on how to treat the tanks so that those 5 tanks never suffer these types of catastrophic corrosion rates moving forward. We can eliminate tribal knowledge in suboptimal SOPs so that your tanks perform at their best level every day for their entire life. All right, so to wrap up, what is it that we do to drive business results across a tank farm? Number 1, compliance becomes our gateway to value. We shifted from being a cost center to becoming a value driver through comprehensive health scans. Second is we start optimizing the way we do maintenance. And if you're anything like your industrial peers, that means that you can expect a 50% reduction in the amount of reactive maintenance across your tank farms. Third is we make better CapEx decisions on when to repair versus replace, and that's a savings of at least $1 million per tank. So in conclusion, before we get to your questions, if this does sound like something you're interested in, keep in mind that it's not all rainbows and unicorns. There are challenges here. Now, there are a couple instances where this may not be a good investment for you. The first and the most important is really around culture. What we've found is that industrial plants that have a culture that embraces change, plants that have strong leadership, this becomes a terrific investment, one of the best that you can make. On the other hand, if you work at a plant where there is weak leadership, or where frontline employees are looking for every opportunity to sabotage a new technology, quite frankly, this can become the worst amount of money you ever spend, and you're going to lose a lot. So think carefully about the culture into which we're bringing this new way. And the other is the initial investment. Frankly, these robots and the services that we've described, they're not cheap. But when we look at the value of the entire tank farm and the impact it has on maintenance and CapEx, this becomes a very powerful investment with a very high return on investment. Okay, so if you're interested in engaging with Gecko and taking the next step with us, there are a few ways that you can reach out. Number 1, you're welcome to call or text the phone number that's listed on the screen. Second is you can send an email directly to me. I would love to hear from you to point you in the right direction here on our side. Or you can go directly into that chat box that we have open right now in this webinar interface and just type in "contact me" with your contact information, and we'll be sure to follow up with you right away. Okay, so with that, we are ready to jump into your questions. And I'm just going to grab a laptop here that has them listed as they've been coming in. I see a lot. This thing is churning quickly. So let's get to your questions. we are. Is my audio okay? Okay. All right. First question. Now this comes from Brian, and Brian wants to know if we have an option for stainless steel. I know, especially in chemical or food and beverage, stainless steel is definitely everywhere. So Chase, David, I'm going to turn it over to you. Can you help Brian understand our approach for stainless steel?
Sure. Today, Brian, we are building scaffold in tough to reach locations. A lot of the ones we do are quite small and easy to do with ladders and whatnot, but in some cases, scaffold are needed to get in the region to get 100% coverage when talking about weldments. And a lot of times what we're doing with stainless is doing crack assessments, but also corrosion assessments. And sometimes a corrosion assessment, we don't need the scaffold, but to get to every T-joint and every weld, we will need that scaffold. We are in the, I would say, late stages of development of a tool that will eliminate that scaffold. So reach out to Ben and maybe we could talk further with you about that.
Good. Thanks for that question, Brian. Okay, moving to Mike T. Mike T asks, what's the surface temperature limit? Chase, if you can speak to that for the robots, then I can speak to it for the sensors.
Sure. For the robots, like the one behind Ben there, it's going to be about 300 degrees or below. There's many different robots that we have that operate somewhere between 150 as their maximum and then up to about 300 as their maximum. And then the phased array robots for weld inspection and corrosion assessments with the higher resolution, but a little bit slower than the rug robot, up to 400 degrees F.
Okay, good. And for the sensors, these guys, the surface temperature limit on those is about 950 degrees Fahrenheit. So thanks for your questions on temperature limitations. Okay, another question that comes in from Tom is, what obstacles can the robots navigate? For example, can it transition from a shell to a conical bottom section? Chase, take it away.
Sure. We've made many transitions. I think every one of them is unique. So getting some pictures of the area of interest, where the transition is, and then getting fabrication or as-built drawings would be very helpful to make sure that we can. If we can't, then it's often that depending on how high it is, we may use like a JLG or some form of access, and we'll scan the conical section separately, and then we'll move the robot to the shell course above and then scan that separately. The two data sets will come together in the final report. It'll look like it was scanned together, but the robot may not transition it depending on the angle.
Okay. Thank you. All right, next question, Chase, this is for you. This is from Rob. Rob wants to know if we can do inspection on process piping.
Sure. Yes, we can. So robotically, we can scan any size of pipe, 4-inch and above. Any schedule of pipe, any size of pipe, 4-inch and above, all the way up to flat. So typically we're doing anywhere from 4-inch to 30-inch pipe or so, or maybe larger. It's no issue. So the robot behind Ben there can do roughly a 20-inch or above with some modifications and whatnot. We have several options. And then for the phased array robot, 4 inches and above. So we have a wide range of tools that we can use, 4-inch and above. Below 4 inches, we can still get data, like filling in T-joints or connections and things like that, elbows or any type of transitions. We can fill in by hand. So you may do 90% with the robot 4-inch and above, and then cover the remaining connections and things like that by hand to get 100% coverage.
Okay. This next question comes from Steve, and Steve wants to know, how often do the sensors take readings? So I think you're referring to these, Steve. Those sensors can take a reading as frequently as every 5 minutes, 5-minute frequency. Now, most of our customers find that taking a reading even once a day is sufficient. But if you need to do it more frequently than that, we certainly can. The real value of these sensors, guys, is number one, knowing where to monitor the hot spots that the robots find. But second is, over time, being able to identify those intermittent high damage moments when corrosion or erosion accelerates very quickly, so that we can then go back and start looking at process data to understand the root cause of those huge increases in corrosion and erosion. So thank you for your question, Steve. All right, next question is from Raja. Chase, I'm going to read this to you and tell me if you need any clarity on it. The question is, can we cover the bottom plate, especially at the annular plate critical zone? So I think this is related to tank floors. Any additional narrative on that?
We have two options. Today, mostly we're talking about in-service inspection while the tank is still full. We have an option for that. And then when the tank is empty, we also have an option for that as well. So reach out to Ben and I can get you some deep technical details on each of those options. But to say more or less in service, we have a swimmer robot that has a phased array probe. This unit deploys phased array. It's roughly a 12-inch probe, and it can cover that annular ring about a ½ inch or so at the edge of the plate, all the way around 360 degrees. And then we also have another robot that could do it out of service as well.
Okay. Good. Thank you, Chase, for that additional insight. Now, here's a question we hear all the time. This one is, if a carbon steel tank has an external coating, how thick can the coating be and the magnets still adhere?
Fairly thick. We do some work in some industries that have coatings that are approaching 1 inch thick of heavy grit epoxy, and it's no issue provided that the substrate they're attached to is more than a few millimeter thick steel, carbon steel. So no issue. And as far as getting ultrasonics through those, if they're in the form like most coatings are, an epoxy base, then it's no issue. We can see through it with the ultrasonics as well.
Okay. Thank you, Chase. Now this question comes from Ahmad. And I know you spoke a little bit to this before, but Chase, can you please tell us a little bit more about scanning a tank floor in service, limitations related to process or temperature, or what type of fluid is in the tank?
Sure. So the robot crew, Gecko and the on-site owner would have to work together with operations to eliminate process flow or eliminate it to a certain CFM inside the unit. The robot needs to have a pretty static environment to float and maneuver inside of the tank. It can work within water, diesel, fuel oil, and other high flash point fluids. And then with the side deployment tool that it's around the corner, we're very close to qualification stages of it. Gasoline and other finished products are now an option here in the near future. But more or less, we need to remove flow from the inside of the tank, make it more static, and the robot will perform just fine.
Beautiful. Okay. Thank you for that. The next question, Dinesh asks, are there any dead zones? So as far as dead zones, I guess what I would offer, Dinesh, is that first of all, if there's a nozzle or something protruding out from the tank and the robot cannot make the transition to it, then obviously that's an area where the robot alone is not going to be enough. And there are also limitations to the types of surfaces to which the robot can adhere, as Chase described earlier, right? And we're in development to help with that. But just reach out to us directly, Dinesh, and we can get more into detail on that. All right, Paul asks a question. Now this is back to the sensors. He says, what is the accuracy of the continuous corrosion monitoring sensor? The accuracy is 1/1000th of an inch, or 1 mil, if you want to think of it that way. 0.001 inches is as accurate as it can be. So highly accurate readings that are coming off this thing. And Paul also asked as a follow-up, how do we install these sensors? How long does it take? And what about piping? So when it comes to installation, if you're just putting it on a tank, especially if we do it immediately following the health scan, which is what most of our customers are doing now, 5 to 15 minutes, and that sensor is installed. And if you want to put it on a pipe or any sort of process piping, there are bands that will wrap around the pipe and adhere the sensor to it. Again, very simple, and it doesn't take much time at all. Okay, Chase, there's a few other questions that have come in the time we have. I'm not sure we're going to be able to get to all of them. Here's one. This comes from Rachel. And the question is, can you give me more specifics on weld inspection? How do you do weld inspection? Chase, why don't you take that one?
Sure. The weld inspection that we typically deploy is very similar to the industry standard that's been around roughly 20 years, as phase array has been working its way to usurp radiography inspections. But typically we're using a very high resolution version of it, of 32 or 64 elements or more, several probes of overlap, and depending on the inspection type, crack inspection type of inspection, we are going to be using very, very highly focused probes. And the overall procedure is very geared towards doing in-service damage mechanisms typically. I think I said earlier, but this will work for nominal thicknesses of 1/4 inch through 8 inch carbon steel material. And then 4-inch diameter and above up to flat, something similar to a storage tank. And then on the robot, it's covering roughly 500 linear feet to 1,000 linear feet per day, which is roughly 10 to 20 times more than if you were to use it by hand. So it's fairly fast.
Okay, good, thank you. This next question comes in from Rajan, and Rajan says, what about intrusive inspection during turnaround? For example, internal shell and bottom floor. So Chase, can you talk a little bit about how we conduct inspection from the inside?
Sure.
And when we would do that?
We'll work with the local team. If you're going to take a tank out of service and you're going through a major cycle, maybe cut a door sheet and do a full inspection process, we can be there on site with you and do the external shell. We may do it from the external to eliminate any excessive cleaning needs from the ID, but I'm sure you will be working to get it clean and remove the debris. But we can scan the shell from the outside. We can do the annular ring and the floor from the inside with the robot, and that would need to be fairly clean and removed debris. And then the roof for any other inspection points, we can help or assist, have an API 653 on site to do the internal and external visual inspections and go through the full checklist of the health of that tank.
Okay, thank you, Chase. All right, and we have two more so far. Bob, he asks, how much does this cost? Excellent question, Bob. Depending on the level of not just the comprehensive health scan, but the level of analytics and help that you need with your maintenance planning, an investment can be anywhere from $10,000 for a tank all the way up to 5 to 6, even 10 times more than that. For example, I know that we're just planning now to do some inspection on tanks that have a 360-foot diameter. So when they're that large, obviously it takes a little more time and effort. But the level of analytics and engineering that you need above and beyond that comprehensive health scan will also impact what the investment will be. Okay, actually, I think this one you pretty much covered. As I scan through here, it looks like most of the other questions we've covered through what was already discussed earlier. So if you have any other questions that we did not cover today, or something pops up after the webinar, again, you have our contact information. Please feel free to reach out. And I do want to offer a special thanks to the production crew here at Gecko. Allie, Mindy, Richard, you don't see them on camera, but we had a fire drill right here in Pittsburgh in our headquarters just minutes before today's webinar. And these guys jumped through hoops and did everything possible. They nearly put the fire out themselves just so that we could be here on time to join you today. So thanks so much to both the Gecko team and our customers and prospects who joined. We appreciate all of you. Take care.